By 1943, a captured Sherman had been hauled into a German ordnance yard and rolled beneath a gray roof of corrugated iron. The engineers gathered around it, expecting confirmation. Not surprise, not fear, confirmation. They had seen the Tiger. They had seen the Panther. They knew what real armored engineering was supposed to look like. Then they opened the engine deck. And inside the American tank, they found something that looked almost insulting. Not a refined tank engine, not a jewel of German-style mechanical precision, but a Chrysler multibank. 5 automobile engines arranged into one roaring power plant, a mechanical bundle of pistons, belts, shafts, and compromise. To a German specialist, it looked like a joke. Then the joke began to explain the war. Because the terrible question was never whether one Sherman could defeat one Tiger in a clean duel. The question was whether Germany could defeat the system that placed another Sherman behind it, and another, and another. To understand why that engine mattered, you have to understand the world the German engineers came from. Their tanks were not built like appliances. They were built like declarations. A Tiger was not only a weapon, it was proof that German industry could force steel into obedience. Thick armor, a high-velocity 88mm gun, heavy plates fitted and welded with the confidence of craftsmen who believed complexity was a form of strength. Even the hull carried that belief. The plates were not merely slapped together. They were cut, stepped, keyed, and joined like pieces of a steel cathedral. The fit mattered. The weld mattered. The labor behind it mattered. A single hull could absorb hours of skilled work before it ever became a tank. Then came the Panther. On paper, it was almost beautiful. Sloped armor, a long gun, a suspension system of interleaved road wheels that spread weight and gave the machine a smooth ride. In theory, that made the Panther stable, elegant, deadly. In the mud, elegance became a sentence. On the Eastern Front, clay and ice packed between those overlapping wheels. Overnight, the frozen mud could lock the running gear solid. And when an inner wheel was damaged, a crew could not simply replace the bad piece and move on. They first had to remove the outer wheels blocking it. One broken wheel could become half a day of labor, sometimes under shell fire, sometimes in snow, sometimes with no spare part that fit quite right. The Germans had made machines that were terrifying when they worked, but they had also made machines that demanded the world bend around them. Special tools, special training, special factories, special recovery vehicles, special mechanics who understood the moods of a bespoke engine. Each tank was powerful. Each tank was precious. And that was the trap. Because war does not only ask what a machine can do on its best day. War asks what happens after the machine breaks. The German answer was excellence. The American answer was replacement. That difference was waiting under the Sherman's engine cover. The Chrysler multibank was absurd if judged as a pure design exercise. It was wide. It was complicated in the wrong way. It joined 5 6-cylinder automobile engines into one unit, as if a committee of civilian mechanics had been locked in a room and told to make horsepower by morning. A German engineer looking at it would have seen every sin at once. Too many moving parts, too many belts, too many places for vibration, too little elegance. But an American production planner saw something else. Factories, machine tools, workers who already knew automobile tolerances, supply chains that already fed civilian engines by the millions. The United States had not waited for the perfect tank engine to descend from an engineer's drawing board. It had asked a colder question. What can we build now? In numbers so large the enemy cannot answer them. The multi-bank was not the soul of a masterpiece. It was the sound of Detroit being drafted into the war. That was the first crack in the German assumption. The Sherman was full of choices that looked inferior until they were measured in time. Not battlefield time, factory time, repair time, shipping time, training time, replacement time. The hull showed the same logic. German armor culture prized exact steelwork, machined edges, skilled welds, careful fit. The Sherman did not apologize for using methods that could move faster. Different versions used cast sections, welded sections, and standardized manufacturing processes chosen not for romance, but for flow. To a purist, this looked crude. To a quartermaster, it looked like victory. Because a tank built only in elite workshops is not simply expensive. It is slow in a way that spreads through the entire army. Every rare skill becomes a choke point. Every custom fitting becomes a delay. Every hand-finished component becomes another place where the front waits for the factory. The Sherman had been designed to escape that prison. Its parts were not treated as personal possessions of one machine. A bogie assembly was a bogie assembly. A hatch was a hatch. A fastener was a fastener. A mechanic did not need to persuade the tank to accept a replacement. He removed the broken unit and bolted on another. That sounds small until you imagine the battlefield after an artillery barrage. A Panther with damaged running gear might need hours of exposed work before it could move. A Sherman with a damaged suspension bogie could often be made mobile by replacing the entire assembly. Springs, wheels, bracket, all of it. The crew did not worship the part. They swapped the part. That was the heresy. The American tank was not designed only for the engineer who built it. It was designed for the exhausted mechanic with cold hands, a crane truck, and 3 more disabled tanks waiting behind him. The deeper the Germans looked, the worse the discovery became. At the front of the Sherman, the transmission housing could be reached without dismantling half the vehicle. At the rear, the engine compartment was built around access. Large panels, practical fittings, components meant to be removed rather than admired. This did not mean repairs were easy. Nothing about repairing a damaged tank in war is easy. But the American philosophy was brutally clear. Do not make a frontline army solve a jeweler's puzzle in a ditch. Give it a machine it can drag back, open up, replace, test, and return to combat. That idea changed the meaning of a knockout. For the Germans, a disabled Tiger could become a crisis. It was too heavy for many recovery assets, too valuable to abandon, too complex to repair casually. A breakdown could turn into a rescue operation, then a transport problem, then a depot problem. For the Americans, a disabled Sherman was often the beginning of a process. Tow it back, strip what was ruined, replace what could be replaced, salvage what could be salvaged. Push another tank forward while this one is being fixed. The German engineer had been trained to ask, "How good is this machine?" The Sherman forced him to ask a different question. How fast does this army recover from damage? That question was more dangerous than armor thickness. It was more dangerous than gun caliber. Because a battle is not a single moment of impact. A battle is a series of returns. The tank that comes back after being hit changes the arithmetic. The crew that survives changes it again. The spare part that arrives before dawn changes it again. And here, the Sherman revealed another alien priority. The German tank tradition had placed tremendous faith in the vehicle as a fighting instrument. The American system placed unusual value on the men inside it as renewable combat skill. Early Shermans had real vulnerabilities. Ammunition fires were feared for a reason. Armor was not magical. Crews knew the risks. German gunners knew them too. But the American response was not to pretend the problem did not exist. It was to revise the system. Better hatch arrangements, better escape routes, better ammunition stowage. On later models, wet stowage helped reduce catastrophic ammunition fires by placing shells in protected containers surrounded by fluid. That was not a feature meant to help the tank win a duel. It was a feature meant to help the crew lose the duel and live. A German officer might see that as defeat built into the design. An American personnel officer saw 5 trained men who could be put into another vehicle. That was the cold mercy of the system. It did not treat the tank as sacred. It treated experience as scarce. A burned-out Sherman could be replaced by steel. A dead crew could not be replaced by a shipload of crates. So the Americans built the machine around survival, repair, and return. The Germans were studying armor. They were actually looking at circulation. Factories sending parts, ships carrying hulls, depots rebuilding damaged vehicles, mechanics feeding the front, crews surviving long enough to learn. The Sherman was not one object. It was a bloodstream. And once the engineers understood that, even the tank's shape began to look different. Its dimensions were not just tactical decisions, they were transportation decisions. A tank too wide for ordinary movement is not merely inconvenient. It is a problem at every bridge, every rail platform, every ship's hatch, every dock crane, every landing craft, every recovery route. The Sherman was not the heaviest Allied tank because it was never meant to be a museum piece of maximum force. It had to cross roads built by strangers, ride rail cars in countries it had never seen, fit into ships crossing an ocean patrolled by submarines, come off docks under pressure, move through ports, depots, railheads, hedgerows, mud, villages, and repair yards. It had to be cargo before it could be a weapon, and that was the final insult to the German engineering mind. The Sherman was designed as if war were not a duel between machines, but a delivery schedule under fire. Because that is what it was. By late war, the numbers made the argument impossible to dismiss. Germany built Tigers in the hundreds and low thousands, Panthers in several thousand more, powerful tanks, feared tanks, tanks that could dominate a field of fire under the right conditions. The United States built Shermans in the tens of thousands, nearly 49,000 of them. Not because every Sherman was magnificent, because magnificence was not the assignment. The assignment was to create an armored vehicle good enough to fight, simple enough to ship, common enough to repair, and numerous enough to absorb loss without stopping the offensive. That phrase, good enough, sounds small. It is not small when it arrives in battalions. It is not small when spare parts arrive with it. It is not small when a damaged tank returns before the enemy has finished celebrating its destruction. The German High Command could point to individual advantages. A Tiger could kill a Sherman at range. A Panther's gun could punch through armor that the Sherman's early 75mm gun could struggle against. German optics were respected. German armor could be formidable. German crews, especially veterans, could be deadly. All of that was true. And all of it missed the shape of the war, because the battlefield was no longer asking which tank was best in isolation. It was asking which industrial civilization could keep pressure on the enemy every morning after yesterday's losses. One side had built predators. The other had built a herd. Not a helpless herd. A moving, repairable, replaceable, supply-fed herd of armored machines backed by factories, ships, cranes, depots, mechanics, fuel, training schools, and replacement crews. A German gunner might destroy the first Sherman, then the second, then the third, But each kill spent ammunition, exposed a position, strained a barrel, consumed time, and waited for the next target to appear. The arithmetic did not ask whether the German shot was perfect. It asked how many perfect shots Germany could afford. That was the quiet terror inside the captured tank. Not that it was unbeatable. It was beatable. That was almost the point. The Sherman could be hit, burned, towed, repaired, replaced, and sent back into the line as part of a machine larger than itself. The Tiger was a masterpiece. The Sherman was a system component, and in an industrial war, the system component may be the more frightening weapon. Imagine the final report crossing a German desk. The first pages would have been comforting. Armor weaknesses, high silhouette, gun limitations, compromises in engine design, manufacturing shortcuts. Proof, apparently, that German design culture remained superior. Then came the pages that mattered. Production rates, interchangeable parts, maintenance access, recovery procedures, crew survivability, shipping practicality. The comforting report became an accusation. It said, in effect, you are judging a river by one bucket of water. The Sherman in front of you is not the threat. The threat is the line of Shermans behind it. The threat is the factory that does not pause for mourning. The threat is the dock crane lifting another hull. The threat is the supply truck full of parts that fit. The threat is the crew climbing out of one wreck and into the next vehicle with the terrible knowledge of men who have already survived. Germany had built tanks that could win encounters. America had built a tank that helped win campaigns. That distinction is everything. A perfect weapon can dominate a moment. A replaceable weapon, sustained by a continent-sized production system, can dominate time. The German engineers had opened the Sherman expecting to find bad design. They did find compromises. They found them everywhere. In the engine bay, in the hull, in the suspension, in the silhouette, in the blunt refusal to make every part elegant. But they had misunderstood what a compromise was. A compromise is not always a weakness. Sometimes it is a decision about which war you are actually fighting. Germany was still imagining the tank as a champion stepping into a duel. America had made the tank into a package in a pipeline. Steel went in at one end, combat pressure came out the other, and no single destroyed vehicle could stop the flow. That is why the captured Sherman mattered. Not because it was the finest tank of the Second World War, not because its crews loved every inch of it, not because it made German armor obsolete overnight. It mattered because it exposed the fatal limit of perfection. Perfection takes time. Perfection demands specialists. Perfection resists replacement. Perfection becomes precious. And once a weapon becomes too precious to lose, the army that depends on it starts making decisions around fear. The Sherman had no such vanity. It accepted loss as part of the calculation. It accepted repair as part of design. It accepted shipping as part of combat. It accepted the factory worker, the dockhand, the mechanic, the tanker, and the crane operator as parts of the same weapon. That was what the German engineers saw too late. They had been trained to admire the finest machine in the yard. The war was being won by the machine that could leave the yard again and again and again. In the end, the Sherman did not have to be the better tank. It had to be the tank that kept coming back. Germany built the finest clock. America built the clock that never stopped.